Hi, this is Mr. Ng going over Geometry Chapter 2 test on February 20th, 2015. Determine the unknown in this pattern. You go from 2 to 6 to 18 to 54, and then it has a blank. Then I noticed that I'm basically multiplying each of those numbers times 3. So I just take 54 times 3. That gives you 162. Choice D. Remember, each of the multiple choice questions are worth 2 points. Number 2 says, which type of reasoning does the following statements demonstrate? All birds have feathers. Robins are birds, therefore robins have feathers. You're going from some general information, talking about all birds. Excuse the bell.
Amanda Newby, please contact the main office. Amanda Newby, please contact the main office.
Then you get very specific that robins are birds. Therefore, robins have feathers. You're going from a general statement to something that's very specific. Therefore, that's called deductive reasoning. Another word I think of deductive is to deduce or reduce. Reduce meaning come up with a conclusion. Question number 3, what is the conclusion of the statement? Remember, we talked about the words if and then. So if you had to write the words if, there's that keyword right there. If the number is divisible by 6, that is my hypothesis, then my conclusion is really right here. Then a number is even. That would be the last choice. Number 4 says find a counterexample to show that the conjecture or this idea is false. Any number that is divisible by 2 is also divisible by 6. So what I did is I wrote down all my numbers here. 8, 22, 36, and 12. And divisible just basically means it can go, you're using division and there's no remainder. So 18 is divisible by 2, that gives you 9, that's a check. So it's saying any number that is divisible by 2, so all of these should be in it, they are. So I have all checks here. But then it says also divisible by 6, so 18 divided by 6 gives me 3, yes. 22 divided by 6 is 3 remainder 4, so that's the reason why 22 is the counterexample of this idea that any number is divisible by 2 but is also divisible by 6, because 22 is divisible by 6 but not divisible by... it's divisible by 2 but not 6. Question number 5, determine if the biconditional, so it's telling us in quotations, 2 angles are complementary if and only if they are both acute, is true. If false, provide a counterexample. So in order to be a conditional statement, both the conditional and the converse have to be true. So the conditionals means I just take out the words if and only if, and add the words if and then. There's my if, and there's then. If 2 angles are complementary, then they're both acute. That is true. Blank plus blank equals 90, and any number I put in the blanks will have to be acute. My converse is, that means I just switch now my my hypothesis and my conclusion. So here's a conclusion. If both are acute, then they're complementary. That's false, because if you did, my counterexample is 14 plus 14 degrees. Those are both acute angles, right? But they're not complementary, and they're not equal to 90. So you get 2 points, and this problem is out of 4. 2 points that you knew was false, and then 2 points if you have the counterexample. Question number 6, for the conditional, if an angle is right, then it measures 90 degrees. Write the converse and biconditional statement. So the converse, again, just means to switch this. Here's my hypothesis. Now I'm going to switch that to after then. I'm going to take my conclusion, measures 90 degrees, I'm going to put that now here. That was 2 points. Biconditional statement. This is also 2 points. You're just going to take out the words if and then, and you're going to add the word if and only if. Angle is right if and only if it measures 90 degrees. Question number 7. Figure is not drawn to scale. Assume that all lines are straight. If the figure above 3 lines intersect at a point, if f is 85, and c is 25, what is the value of a? So I said f and b are congruent, they're vertical angles. Notice how they share that same pair of intersecting lines. That's 85, and this is 25. Then I just need something to add to 180, therefore a is 70. Better choice C. Question number 8, I have a proof here. Copy and complete the following proof. Angle QPS is congruent to angle TPR. That's my given information. That goes there. I asked you guys a cross-off question. Reason B, the reason why is I don't want you guys to go from statements A to B. All they do is they're taking out the measure. You have an angle and then its measure is congruent. To me, essentially the same. Statement C, they have angle QPS. Notice how that's a big, and you go from QPR to RPS. Those are smalls. That's angle addition. Possible, again, the common mistake is thinking it's segments. TPR, it's a big angle. TPS is a small plus a small. And if you're looking, then you have to think about how can I use this given information. Well, QPS is equal to QPR plus RPS, so I kept the first one. Then the second one, all I did was I used this statement here. Every time I see TPR, I write QPS. There's TPR. I'm going to write QPS on that second equation. Now the reason why I do that is to show that every time I write QPS, I write all of this information, right? Every time I see QPS, I'm going to write angle QPR plus RPS. Well, I write that here, and now I have these two equations equal to each other. I did substitution, and then notice what's the same on both of those is RPS. So if I subtract RPS from both sides, subtraction property of equality, I get QPR equals TPS. There's a scoring for the problem. Question number 9. You have algebra says given this, prove x equals 1. I did tell you guys to cross off a couple of these. That's given information. If you notice what they're doing over here, essentially they're moving the 2x to the left side, so that's why you have 2x and 2x. That's called subtraction property of equality, because these will cancel. And you're just left with 8x minus 5 minus 2x, and you combine like terms here. That'll give you 6x minus 5 equals 1. Then to move this minus 5, you're going to add 5 to both sides. That's addition property or addition property of equality. And to get rid of that 6, you'll divide both sides by 6, division property of equality. There it is, and you get x equals to 1. Question number 10 says 1 and 2 are vertical angles. We kind of already know that. It says prove 1 is equal to 2. So notice here it doesn't say 1 and 2 are vertical angles. It doesn't say that right here, which means you can't write given for number 1. If you look at your picture, 1 and 3, those are linear pairs. 1 plus 3 equals 180. Linear pair postulate or definition of linear pair. And 2 plus 3 equals 180. What's the same in both of those? I noticed that they both have a 180, so there's my substitution. Every time I see 180, I'm going to write 1 plus 3. Here's 180. I write 1 plus 3. So essentially you're getting, these two equations are equal to each other. 1 plus 3 equals 2 plus 3. I notice that both of them have a measure of angle 3, so if I subtraction property of equality, or addition property of equality, you're adding a negative number, then you'll get angle 1 equals angle 2. Question number 11, find the measures of two supplementary angles, angle M, angle N, if measure of angle M is equal to 6x. I told you guys to change that to plus 3, and measure of angle N is equal to 2x minus 7. The key word here, supplementary, should get you to the equation blank plus blank equals 180. Fill in your two angles, and you'll solve to be x equals 23. If you got there, I gave you 3 points out of 4. If you just got blank plus blank equals 180, I give you 2 points out of the 4. And remember, it tells you find the measures of those two angles, which means you have to x equals 23. Substitute into each of the equations, you should have gotten 141 and 39. Notice how those are supplementary. Question number 11. Here's my picture. AB equals BC, that's given. AC equals AB plus BC. If you look at this picture, notice how AC is a big. And what you're doing there is you're adding segment addition postulate. Then we notice something. We notice that you go from this equation to that equation. So what's the only thing that's the same? This is the same, this is the different. What they did there was a substitution. Every time you see AB, write BC. There's AB, write BC. Substitution. Well, if you add or combine like terms or simplify BC plus BC, that's 2BC. In the division property of equality, divide both sides by 2 and you'll get 1/2 AC equals BC. Question number 12. It's a blank proof. You had to come up with that. Here's your picture. Prove 1 equals 3, and essentially what you're doing is you're not using alternate exterior angles. So 1 and 2 are a linear pair. It's given. 2 and 3 are supplementary. Given. Essentially what I'm doing is I'm taking 1 and 2 now. Now we know that it's a linear pair. It should be 1 plus 2 equals 180. You're making those equations. Linear pair postulate. Now I'm taking this one and making it an equation. 2 plus 3 equals 180. Notice how they both have 180 in common. Every time I see 180, I'm going to write 1 plus 2. There's 180, write 1 plus 2. You're essentially putting the two equations equal to each other because they have 180 degrees in common. I see angle 2 there. All I have to do is subtraction property of equality, and then I've finished.